Alright guys, more review of radicals and rational exponents because you have a test coming up really quick. So we want to make sure that you are ready. Okay, so we are going to start by writing the expressions in radical form. So that means that I need a root. Oh, sorry. Silly bell. Okay, so remember on your fraction, the top part is your exponent and the bottom part is your root. So we want to keep our 10b together. The top part is your exponent, and the bottom part is your number on your shelf. So I have just written this in radical form. Likewise, if you want to go backwards, let's look at number 4. Then you take whatever's on the inside, so 10b, and you're going to put parentheses around it, especially if it's more than one term. If it's just one term, it doesn't need it, but this guy does. Then the exponent goes on top, and the number that sits on your shelf is the bottom. Okay, so let's look at number 5. We are going to simplify these. And we only want positive exponents. So we'll start by multiplying our number. 4 times 2 is 8. And then we need to combine our fractions. So on the x's, I have 3 halves, and I'm going to be adding that to 4 thirds. If you want to, you can do that in the calculator, or you can know that we're going to change this by multiplying by 2 and change this fraction by multiplying by 3 so we can get a common denominator. 3 times 3 is 9/6 and 4 times 2 is 8/6. And then you add straight across, so 17, and you keep your denominator. So I am just using my fraction rules to add fractions together. That's what this is. Again, you can just use your calculator. So 17/6. And my y doesn't have a pair, so there she is. It's fantastic. Okay, let's simplify. Number 8. Okay, so 175. We're going to divide and make a factor tree. So let's see here. 175, well, we'll go with, let's see if we can divide by 5. Oh, so nice. So 175 divided by 5 is 35, and 35 divided by 5 is 7. So with this, I can rewrite, and that's what I want to do because I just want to show you. So 175 is the same thing as 5 times 5 times 7, and then we have our x. So there's no number on our shelf, which means it's a 2. So I'm looking for pairs. So the only thing I see a pair of are my 5s. So that means that one 5 goes out of the radical and the other 5 goes away. I'm left with 7x underneath my radical, and I have 5 in the front. So this is your answer. Okay, let's look at number 9. On number 9, you can only simplify radicals if they have the same number under their root and the same number sitting on their shelf. So we should probably reduce these to start. Let's look at 18. 18 divided by 2 is 9, and the 9 is made up of 3 and 3. And then 8 divided by 2 is 4, and 4 is made up of 2 and 2. So in my 18, I'm left with a 2, and on my 8, I'm left with a 2. That's good, they match. And then I want to, oh, maybe I have another pen. Oh, I do. I want to take out one of my pairs. So take out a 3 and the other goes away. There's my other pair. Take out the 2 and the other goes away. And if I have a leading coefficient already, they get multiplied. So multiply. Okay? All right. So on my 18, I have a negative 3 here. I'm going to take out a 3. So negative 3 times 3 is negative 9. Root 2 is left. And then this guy, on my 8, I'm going to take out a 2, so I have a negative there, so that's negative 2. Root 2 is left. And then lastly, I have negative 2, root 2. Now these all three have the same roots, they have the same number on the shelf and the number underneath the roots. So 9 minus 2 is negative 13 root 2. So that is simplified all the way. Okay, let's see what else we have on the other side. Oh yeah, on number 11, just remember all you have to do is multiply your numbers underneath your radical. 15 times 3 is 45. Okay, and then we're going to reduce. So 45 is 9 and 5 is 3 and 3. So I have a pair of 3's. One goes out, the other goes away. And I'm left over with 5 under my radical. So my answer is 3 root 5. Oh, I love it. Okay, your hint on number 12, we did one like this yesterday. Distribute. Okay, let's see what else we've got. Oh, the same thing on like 13 and 14. You have to distribute these, so you have to distribute the roots and the number, the leading coefficients, to each of the following terms on the opposite parenthesis. Okay, we've done that a lot too. So if you're confused, you should watch yesterday's video. I'll do one like 17. On this, you can reduce your radical because I didn't get a chance to do one of these yesterday, so we're going to do one today. But you don't have to. So my suggestion for you is to multiply by just whatever your radical is because we're rationalizing the denominator. So we're going to multiply by root 20 to my root 3 and my 3. So on the top part of my fraction, I have 3 root 20 and I have the square root of 60 because I multiply. 3 times 2 is 60. And then underneath, I have my 3. And then right here, remember, I have 20 times 20, which is already a pair. So when you have a pair underneath the square root, one of them goes out and then the other one goes away. And when it comes out, it needs to be multiplying. So it's going to be 3 times 20. And then we're going to reduce our radicals. So let's see. 20 goes to 2 and 10 and 2 and 5. And then 60 is what? 2 and 30, which is 2, and 15, which is 3 and 5. Okay, so I have pairs of 2 and 2, and then this is what will be left underneath my radical. Okay, so on the top, when I take my 20 and I reduce, I'm going to multiply 1, 3 by my 2. So that's 6, and then this guy goes away. What's left over is 5. And on my 60, I'm going to take out a 2. 3 and 5, 3 times 5 is 15. We don't want to leave it as 3 times 5 underneath my radical. And then here, 3 times 20 is 60. Okay, so now I want to show you one more thing. I can reduce this, and I know I can reduce because 60 is even, 2 is even, and 60 is even. So I'm just going to kind of migrate into 18. I'm really sorry about that, but that's what I'm going to do. Okay, I'm going to take out my greatest common factor between 6 and 2 and 60. So 6 and 2, the greatest common factor is 2. That leaves me with 2 times 3 root 5 is 6 root 5. And 2 times 1, I don't need a 1 out in front. And root 15 make this. So basically, I'm undistributing. I'm taking out my GCF, which is going to be a 2. Oh, I made it all unpretty. How sad. Okay, on the bottom, I'm going to do the same thing with my 60. I'm going to take a 2 out of 60, which leaves 30 left over. Now, do you see how you have on the top and the bottom a 2 divided by 2? Well, 2 divided by 2 is the same thing as 1, so we can reduce, and our answer is going to be this business that we have here. So our answer for this problem, let's shift this. I know, I'm really sorry I ran into the other problem, but it's 3 root 5 and root 15 all over 30. So this is your answer to that problem. Okay? You can only reduce your radicals if you have number in each of your radicals and they're adding together. If they're not adding together, then you just look at your leading coefficient and your denominator, but when they are adding together, you have to look at each of the pieces individually. Okay, let's look at number 22. So for this problem, in order to rationalize your denominator, you have to multiply by the opposite, and you have to take that 2 with you. So you're going to multiply by 2 minus root 3 on the top, and you have to multiply by the same thing on the bottom. This is because if you multiply by the positive and the negative version, it's going to cancel out any middle terms, and we're definitely going to get rid of the root in our denominator, which is why we're rationalizing. Okay, so again, if you weren't sure on number 13, we're actually doing that right now. Because we're multiplying the top, and the top has 2 terms in each of the spots, and so did 13. So we're going to distribute this 4 to the 2 and the negative root 3. Okay, yeah, I'm going to do it underneath, just so I have enough room. Okay, 4 times 2 is 8. And 4 times negative root 3 is negative 4 root 3. Then I have to make sure I distribute my negative 3 root 2 to my 2 and to my negative root 3. Okay, so negative 3 times 2 is negative 6 root 2. And then negative 3 times negative 1 is positive 3. And then I have root 2 times root 3, which is root 6. Okay, underneath, all you have to do for your shortcut here is you need to multiply your first terms and your second terms. So we've got 2 times 2, always put a minus sign, and then I don't have any leading coefficients, so it's just going to be 3. Okay, and if you want more understanding of why, then you need to watch Friday's video. But it's a shortcut, so that you don't have to write all of the business that's in between. Just makes it better. On the top, I can't reduce anything. 8 minus 4 root 3 minus 6 root 2 plus 3 root 6 all over, what have we got here? 4 minus 3, which is 1, which I don't need underneath, so I'm just drawing my box around it. All right, guys. Here, let me show you this really fast in case you're like, man, I'm so confused. Okay, so on the bottom here, when you have 2 plus root 3 times 2 minus root 3, multiply my 2 times 2 and I get 4. I multiply 2 times negative root 3 and I get negative 2 root 3. I multiply root 3 times 2 and I get 2 root 3. And I multiply root 3 times root 3 and I get negative 3. Okay, well, negative 2 root 3 and 2 root 3, when I add them together, I make 0. Because if I have negative 2 and I add 2 to that, that is 0. If I have positive 2 and then I take away 2, that's also 0. And then we have minus 3. And that is 1, which is exactly what I got, which is the shortcut. You just have to multiply the outsides and the insides. All right, guys, hope you had a great day. Let me know if you have any questions. Bye.